Hopefully you use the Pythagorean theorem and get, what, 34 we said? Okay, so AT or TA is 34. Finding the missing angles, you're going to have to use at least one inverse trig function. Brett, what did you use?
Inverse of tan.
Inverse tan for, okay, so which angle were you finding?
T.
T. Okay, so you could say the tangent of angle T is equal to what?
Oh, it's 30 over 60.
Okay, so then T is equal to the inverse tangent of that same ratio. Okay, and Brett, what'd you get?
61.
61 degrees?
Yeah.
Okay.
Point whatever.
Point so forth.
Point.
Sure.
0.9.
61.9.
Yeah.
A little bit closer to 62. If you know angle T, then we could find angle A pretty quickly. Angle A, then probably the easiest way is just to take 90 and subtract that, and you get this last one. You get angle A, therefore, minus 61.9, which is what? So angle A is forced to be 28.1 or so. Okay. You could also, if you wanted, you could do tangent if you wanted. You could say tangent of A is 16 over 30, inverse tangent, and so forth. There's a lot of ways to do this. Probably the quickest way is find one, subtract 90. Okay. I'd like to jot down, just as a recap of what we've gotten so far, like strategies we've used to find sides or angles, so forth. So some strategies we've had to find missing sides inside a right triangle. So we have, first one is Pythagorean theorem. For in the right triangle, Pythagorean theorem always works if you know two of the three sides. If you only know one of the three sides, then we can resort to trig functions. We can resort to trigonometric functions if we need. Like our two major players. If we have missing angles, what if we knew two of the three angles? Then we can always use the sum of the angles is always 180 degrees. If you know two of the angles, we can find a third using that idea. Or what if we only know one of the angles? We only know that we have the right triangle. Then you could resort to like inverse trig functions that we saw yesterday. So set up a sine ratio and then find the inverse of that ratio using your calculator. Problem though. If we leave the world of right triangles, only one of these four things still holds. We can only keep using one of these four things. We know which one of the four you're allowed to keep using if we stop having a right triangle. Which one of those four things are you allowed to keep using? Yeah, this is the only thing that keeps working if you have a triangle that's not a right triangle. Which means it becomes very hard to find missing side lengths. So there's none of these strategies work. And then we can only find missing angles if we happen to know if we happen to know like two of them. So our life becomes a lot more difficult if we're trying to solve just general triangles, not just right triangles. Okay. As I mentioned earlier, we're going to discuss two strategies. One is called the law of sines, and the other is called the law of cosines. And these strategies are going to apply to any triangle whatsoever, not just right triangles. Okay. We're not going to spend a ton of time discussing like where they came from, like how you come up with these formulas, or kind of do a ton with. But I do want to expose you to them and kind of discuss, at least like get a nominal like work variability with them. Okay? The first one is the law of sines. The law of sines says the following. In any triangle, say we'll call it ABC. And recall from before that this is the general way to label a triangle. We call the angles by capital letters, and then the sides that are opposite of them, that are across them, we label with lowercase letters. For any triangle whatsoever, the following relationship holds. So that the ratio of the sine of an angle over its opposite side. So sine of angle A divided by the length of the opposite side of little a is equal to the sine of angle B divided by its opposite side. And in addition, the sine of the third angle divided by its opposite side. These proportions are always true within any triangle whatsoever, whether it's a right triangle or not. These proportions always hold. Okay. These work for right triangles. They work for any triangle, whether it's acute, obtuse, right, however you want it to be. This ratio holds. It's called the law of sines. Okay. So if we know, say, 3 things within a given triangle, then we should be able to set up a proportion so that we could find most other parts. Say, for example, if I gave you this kind of crazy looking triangle, and I told you that, I'll say this angle is 35 degrees, this angle is 105, this side is 7, I don't know what this side is, and I also don't happen to know what this side is. If of the 3 pieces of information I know, if I know the length of a side and its opposite angle, then I should be able to use the law of sines somehow, some way. For example, I know the measure of this angle and its opposite side. So the sine of this angle divided by its opposite side should be the same as, and now I'll pick a ratio from one of the other sides, one of the other missing sides I'm looking for. So like where should we start? You want to start with find little a or little c? Little c. So then that means that the sine of this, so this proportion should be equal to the proportion of the sine of this angle divided by its opposite side. Or the sine of 105 divided by its opposite side. Oh look, I have a proportion, and I know all but one of the pieces. How do I solve this algebraically? Do you solve a proportion?
Cross multiply.
Cross multiply. So if I cross multiply, you get this thing algebraically. You get c times the sine of 35 is equal to 7 times the sine of 105. And then I'll divide to get c by itself. Let's divide by whatever this number is. So c is equal to this ratio. Word of warning, sine of 105 divided by sine of 35 is certainly not equal to the sine of 105 over 35. This thing is not the same as sine. This thing and this thing are not the same. Do not do this. It's a bad idea. Just type in the word sine twice. It'll be a lot better. Okay. So sine 7 times sine 105, divide that by sine of 35, and we'll get our measure for angle C. Or, excuse me, for length C. C is a length of about 11.7. Okay. On your own, use this same process, set up a proportion and solve a proportion that will find the length of side A. Okay? Use this diagram to set up a proportion and to solve that proportion to find the length of side A. You may need to figure out what the angle measure for angle A is before you go any farther. Hopefully you got this proportion solved, and you should get A is approximately 7.84. For any triangle, there's a second law called the law of cosines that we can use to find other pieces. Now, what's nice is even though the law of cosines looks a little more complicated, I like the law of cosines more. My reason for liking law of cosines more is the law of sines only works if you know, you have to know of side, to know an angle and its opposite side. You have to know one of the full proportions in order to use the law of sines. Versus law of cosines, you don't quite need that. In the law of cosines, you can actually get away with only knowing like two sides and the included angle. It's kind of cool. You can also rewrite it if you know all three sides, then you can use the law of cosines as well. Okay. This is 3 different ways to write basically the same formula. Notice in each of these 3 formulas, what we're doing is we're picking a side. So like in this case, we pick a side. And then what we're saying is that if you square, if you square this, it's equal to, if you square the other 2 sides and add them together. And then if you then take that number and subtract off twice of multiplying those sides together and multiplying by the cosine of that included angle. Okay. This one is the same pattern. If I want to know this side, I can square this side, and then that should be the same as square each of these, add them together, take away twice of these multiplied times the cosine of that angle in between. Same with C. If I want to know this side, I'll square it, and that should be equal to each of these squared and add them together. And then I take away twice of, multiply the sides, and multiply the cosine of this included angle. This is an observation. What does this formula look a lot like? This looks an awful lot like the Pythagorean theorem. Try this. What if the included angle is 90 degrees? What if C is 90 degrees? If you have a calculator, try to find the cosine of 90 degrees real quick. 0. So what's anything times 0? 0. So then if the cosine, if you have a right triangle, then this piece of the law of cosines would be c squared equals a squared plus b squared minus, well, anything times 0 would be 0. So the law of cosines is really just like a generalized form. It's like think of it like the Pythagorean theorem, but for any triangle whatsoever, not just a right triangle. Okay? It's basically the Pythagorean theorem, and then we're going to actually do a little adjusting. We'll subtract off a piece depending on whether or not it's a right triangle or not. If it's a right triangle, then this is just 0, and you get just your Pythagorean theorem. If it's not a right triangle, then we have this like extra factor to account for it not being a right triangle. Okay. If you are like calculator or like programming people, I have a couple of like freshmen that are into calculator programming early in the day. Like they program, say, like formulas to make life easier for themselves. This might not be a bad idea. Like it's not a terrible idea. You have to get to know and love the freshmen.
If I know them, then maybe I can get them programmed.
Can we still teach them?
Oh,
Sure, maybe one day. Oh, it's not a bad idea. We can do an exchange program.
Wait, who are they?
Okay. Find the length of this missing side. We'd call this side little b because it's opposite of side b. You can call it whatever you want, but I'll call it little b because it's opposite of angle b. Notice that the important information to find a side in our general triangle, we need to know side, side, and the measure of the included angle. Do we know that? Side, side, measure of the included angle. Sure. So let's plug and chug here. B squared is equal to side squared plus side squared minus this factor, twice of each of the sides multiplied together times the cosine of the included angle, which is 160. So b squared is equal to this stuff. So this is all just numbers. Figure out what this, get a value for this stuff. 15 squared plus 11 squared minus 2 times 15 times 11 times cosine .
I got a negative.
So then b squared is equal to about 490.66 or so. So if b squared is 490.66, what's the value of b?
Approximately.
Is approximately what, Ben?
22.15.
So then the length of this missing side is about 22.15.
I do. In this area.
So direct application of the law of cosines, plug and chug, solve. B squared is 490.66. B is approximately 22.15.
From your parents. It's my guess.
No.
What the?
All right.
Never really been.
We need to solve.
I've actually been.
If you don't have the law of cosines programmed into your calculator, it can be a pain to use. So you may want to try to minimize how often it's used. What I mean by that is, like, it's a good idea. So if I ask you to solve a triangle, if we use it once, like we could find, say, a missing side. Like if we look at the second example, I'll come back to the first one. If I want to solve this triangle, it might be a good idea to use the law of cosines to figure out this side. Once you know this, now you could use the law of sines to find the other angles. Because then you could set up a ratio here, and then like a ratio of the other angles. You go from there. You could use other methods. You don't always have to use the law of cosines. You're going to love example 3. Just a second. Okay. The nice thing about the law of cosines, is one of the reasons why I like it the most is because you can use it to find angles even if you don't know any one angle. You can use it if you know all 3 sides. You can actually calculate the angles of a triangle. So let's. How about we pick an angle we want to find? What's an angle we'd like to find? We'll start with C.
Yeah.
We'll come back to B. Okay. I want to find angle C. Problem, I don't like having anything that's just like angle C equals, but I could look at law of cosines. Because say if I'm looking for C, look at this guy. I have this particular equation, or any of them, but this one in particular uses all of these pieces are just side lengths. And then I could use this to get the cosine of an angle by itself. If I could solve for the cosine of an angle, then I could use just that inverse idea to get the angle, to get out the angle. So I'm going to use this idea. I'm going to use that guy here. I'm going to pick, say, this formula. C squared equals A squared plus B squared minus 2 times A times B times the cosine of angle C.
Oh,
You could do this one of two ways. You could first, you could just plug in everything we know and solve for angle C. Or we could rewrite this formula so that we just get like cosine of C is by itself. Which way would you like to do this? Do you want to solve this by plugging everything first and then simplify? Or do you want to just just rewrite this formula so we basically get this thing by itself first? I personally like getting a formula and then plugging it at the end. I think the numbers get in the way. Personally, it's my opinion. So let's see what we can do. If my goal is to get, this will be a little exercise in algebra. If I want to get this thing by itself, first thing I want to do is get rid of any adding or subtracting that's going along to this term here. So I'm going to start by subtracting each of these things from both sides. Cancel these things out. So you get this thing, C squared minus A squared minus B squared. Is equal to this thing. That's only 2 steps. So what do I do next to get cosine C by itself? I'm trying to get this thing by itself. Divide by what? Let's divide by whatever this chunk is. You may have like an odd question on this one, but yes, you would be expected to know. So for some of you, you might like plugging in the numbers better. You can do it. This is algebra that in this course you should be expected to be able to rewrite a formula. So, well, what's nice is that now you know what the cosine of C is equal to. So at this point, let's plug in the things we know. So let's plug in the length of C, A, and B. Well, these little things represent, we call our naming pattern. Our naming pattern is like the little letters across. So let's plug in the things I know. So let's simplify the top, simplify the bottom, and then we'll divide those things. So let's take 30 squared minus 29 squared minus 18 squared. Or negative positive. So inverse cosine of 265 over 1044. Well, should give us what angle C is.
75.2.
Sure. Whatever. Okay. That's a lot of work for one angle. Okay. If you wanted, if you were intrepid, you could just do this again, repeat, wash, rinse, repeat, and find the other angle. Find another angle. It might be easier to, now that you know this is 75.2, to find other angles, it might be easier to use the law of sines from here on out. So it might be easier to say, oh, well, since law of sines is just a nice little proportion, you can say sine of this over 30 would be equal to, how about sine of over 30 is equal to, let's pick another ratio. Let's pick a second angle we want to find. A. So then that would be what, sine A over 18? And we could use the law of sines to find. So you can use the law of sines, so it would be a lot quicker. Just proportion, hammer it out. Find the missing angle. Once you know two of the angles, did you waste your time doing the law of sines again?
No.
No, what should you probably do? Just subtract it from 180.